Hi everyone. This is a lesson about multiplying polynomials. It's section 4.6 in your book. So we're moving on from where we left off. So what we've done in the past, if you remember, we had a monomial term that we multiplied into, in this case, a trinomial. Okay, so that we add our exponents because we're multiplying, and we're going to multiply the coefficients. So I'm going to go ahead and erase these arrows so I can draw them as I do them. So 2x times 3x squared is 6x cubed. 2x times negative 4x is negative 8x squared. And then 2x times 1 is plus 2x. So that is using the distributive property, and we are adding our exponents with the variable and multiplying those coefficients. So this is a monomial times a trinomial. Okay, and all we do is distribute. Okay, but now we're going to expand that idea a little bit, and we are going to multiply a binomial times a binomial. Okay, and we're going to do exactly the same thing. We're going to distribute, but we have to distribute both the terms in the first binomial to both the terms in the second binomial. So this is what this is going to look like. So watch this. We're going to distribute the 2x to the 3x. 2x times 3x is 6x squared. 2x times negative 2 is negative 4x. 5 times 3x is plus 15x, and 5 times negative 4 or negative 2 is negative 10. Okay, so if you notice now, we have two terms in the middle that we can add together because they're like terms. So 6x squared, nothing to combine that with. Negative 4x plus 15x is plus 11x minus 10. And so we end up with a trinomial, and this will happen often, most of the time when we multiply two binomials together. So we have this little acronym people like to use, and it's called FOIL. And I think foiling is something you do when you put foil on your pan to bake something. However, some people like to call this foiling. We're not foiling, we are multiplying. But anyway, watch this. This is kind of fun. So if you notice, 2x is the first term in the first binomial. And so 2x times the 3x. 3x is also the first terms, so we call that first, the first terms. It's an acronym to help us remember that we have four terms that we have to multiply together. So 2x and 3x, those are the first terms in the binomials. Notice that 2x and negative 2 are the outer terms. That's what the O stands for, outer terms. And then we do 5 times 3x. Notice those are the inner terms of the binomials. So those are inner. And then the last terms are the 5 and the negative 2. So first, outer, inner, last. First, outer, inner, and last. Okay, just an acronym to help us remember the order that we need to use. I think the arrows are helpful. It's just distributing each term to both terms in the second binomial. So anyway, that's what foiling is. Actually, it's not. Foiling is what you put on your pan. We are multiplying and distributing. All right, so let's do some practice. I like the arrows. I think you should use the arrows 100%. So x times x is x squared. X times -1 is -1x. 4 times x is positive 4x. 4 times -1 is -4. We have some terms in the middle we can combine. Our outers and inners can always be combined. And so -x plus 4x is positive 3x and minus 4. So there you go. First, outer, inner, and last. And the outers and the inners can always be combined. All right, let's do the next one. 3a times 6a, 18a squared. 3a times 5 is plus 15a. -2 times 6a is -12a. And -2 times 5 is -10. Look. Whoops. I don't know why that happened. Wait. This is supposed to be positive. I don't know what hit the eraser there, but something did. Okay, so we're going to combine those. And we're going to get 18a squared plus 3a, 15 minus 12, minus 10. Voila, done. All right, another one. Notice how our signs are different in our binomials. So they kind of give us different signs here. A negative and a positive. Just, you don't really have to think about that, but just think about, in this case, -1 is this is -1, this is -4. Okay, think of it as that and distribute those values. All right, so here we go. 2x times x is 2x squared. 2x times -4 is -8x. -1 times x is -x. -1 times -4 is positive 4. Combine the middle two terms, 2x squared minus 9x plus 4. Final answer. These are all final answers. Trinomials. All righty. The next step up would be that we can distribute a binomial. So here's a binomial. And look, this is a trinomial. Okay? Same exact principle. We're just going to distribute everything in the first term binomial to every term in the second trinomial. Okay, so I like to do these in a way that makes it easy to add my like terms together. So I do something like this, where I'm going to make rows where I distribute the -3 to all of those three terms, and then I'm going to distribute the -2 to all of those three terms, and then I'm going to combine my like terms, and I'm going to line them up vertically so it's kind of easier to see. So let's do this. 3x times 2x squared is 6x cubed. 3x times -5x is -15x squared. Don't forget that you're multiplying those coefficients. 3x times -4 is -12x. Now I'm going to distribute my -2, and I'm going to line up my like terms. So watch this. -2 times 2x squared is -4x squared. So I'm going to put it under the x squared term from the first distribution. -2 times negative 5x is plus 10x. Negative 2 times negative 4 is positive 8. And now I'm going to add these together. 6x cubed minus 19x squared minus 2x plus 8. See, it's real easy if you line them up vertically like that. It's real easy to just add your like terms. Just an organizational tip. All right, so standard form, we'll oftentimes talk about standard form of polynomials, and that just means that they're in descending powers of the variables. So if you look up here at this previous answer, we notice x cubed, x squared, x to the first, and then just the constant term. So because x is in descending powers, that means it's in standard form. Okay, so let's do a couple more. We've got a little tricky one with two variables, and then we're going to solve an equation. All right, so here we go. Let's use some orange. All right, I'm going to distribute my 2, and then I'm going to distribute negative y. So 2 times 3 is 6. 2 times 5y is plus 10y. 2 times negative 4 is negative 8y squared. Now distributing the negative y to 3, I get negative 3y. So I'm going to put it under the y term from the previous. Negative y times positive 5y is negative 5y squared. And then negative y times negative 4y squared will be positive 4y cubed. And the y cubed didn't have a place in the first distributing of positive 2, so we just give it its own little column. And so our final answer for this will be 6 plus 7y minus 13y squared plus 4y cubed. Now that's not standard form. If you notice, the highest power of y is the last term. If I were to want to write it in standard form, I would just turn it around. I would say 4y cubed minus 13y squared plus 7y plus 6. And that's standard form. All right, 2 more. Next one's going to be pretty easy. We'll distribute the y. Y times y cubed, or y squared is y cubed. Y times negative 2y is negative 2y squared. Y times 3 is plus 3y. 2 times y squared is 2y squared. Uh-oh, I see something's going to happen. 2 times negative 2y is negative 4y. And 2 times 3 is 6. Add them up. Y cubed, ooh, nothing. Negative 2y squared plus 2y squared is 0 minus y plus 6. So just put them together. Y cubed, it's okay that we don't have a y squared term. That happens. Perfectly good answer. All right, we like when interesting things happen. So now we're going to get some really interesting things that happen here because we have x's and y's. So, but the process is always the same. 2y times xy is 2xy squared. 2y times negative y squared is negative 2y cubed. 2y times 3x squared is plus 6x squared y. X times xy is x squared y. So I'm going to line that one up under the other x squared y, and the coefficients are just 1, so it's just 1, and they're positive, so I'm going to put a plus there. X times negative y squared is negative xy squared. Notice, lining them up under their like terms. X times 3x squared is plus 3x cubed. I don't have an x cubed from the first distribution, so I'm just going to give it its own column. And then I'm going to add them together. So 2xy squared minus an xy squared gives me just 1xy squared left over. Minus 2y cubed, not doing anything with that. 6x squared y plus 1x squared y is 7x squared y plus 3x cubed. Perfectly good answer. This one's a little trickier about standard form. Sometimes we like to pick a variable that we're going to descend and then the other one will ascend. So watch this one. I would do it like this. 3x cubed. Now I'm going to go for my x squared term plus 7x squared, and we introduce a y there. And then we're going to descend x again, and watch how y ascends just naturally, minus 2y cubed. So this would be standard form for this guy. My x's, this is kind of cool. My x powers ascend, oh wait, where am I? Okay, my x powers descend while my y powers ascend. Kind of fun. All right, solving equations. Okay, I missed a G. This is actually my third attempt at making this video. I'm hoping it's working. Anyway, so I've erased it a lot and started over. How fun. All right, so if you notice, this is an equation. It's got an equal sign. It's got binomials on both sides that we need to multiply. So what do you do when you don't know what to do? You just do what you know how to do. You just do something. X times x is x squared. X times 3 is 3x. 4 times x is 4x. 4 times 3 is 12. Let's do the other side. X times x, x squared. X times 5 plus 5x. 1 times x is just x, and 1 times 5 is 5. So we have some like terms we want to put together. X squared plus 7x plus 12 equals x squared plus 6x plus 5. All right, now, we don't know how to solve equations that have x squareds in them, but when all else fails, just try something. It seems like we should want to put them together. So let's do that. Oh, look what happens. Yay, they go away. Because we don't know what to do with them anyway. Yet. But we will learn. Okay. All right. So now we're back to something familiar. I've got x's on both sides. I want to get x's on one side and numbers on the other. So 7x minus 6x is x plus 12 equals 5. And I'm going to subtract 12. X equals negative 7. So there you have it. Okay, so remember what we're doing. We're just using the distributive property. There's a good example of the distributive property right here. Use your arrows. I think arrows are very important to help you keep track. I like the idea of making rows for each distribution, because if you make a mistake, it's easier to find it that way. The binomials, I don't make rows for those because we end up with 4 terms. Remember what those 4 terms are: first, outer, inner, and last. Okay, just draw your arrows. Alrighty, give your homework a shot. It's listed on Canvas. Have a good day.